Educational Communications and this station present Environmental Directions with Nancy Pearlman. On this series, we explore the effects of human influence on the Earth's ecosystems and discuss solutions to environmental problems which affect the quality of life on this planet. Environmental Directions gives you the kind of information you need to help you participate in decisions impacting your community, the nation, and the world. Now, here's your host, Nancy Pearlman.
Hello. We're going to be talking about lithium with my guest, Jack Lifton. He is Director of the Industrial Policy Institute, CEO of Jack Lifton, a metals industry consultancy. He is currently the advisor and physical and chemical engineer with One World Lithium. He is editor-in-chief of Investor Intel Corporation, creator of the term technology metals, and is a founding co-principal of Technology Metals Research, as well as being a member of numerous professional associations. Welcome. It's a pleasure to have you with us.
Thank you.
You have been involved in the metals industry for a long time.
This is my 60th year.
Consequently, you have worked with many organizations, companies,
Yes.
because you are very interested in making sure that we have better use of lithium, electronic uses. Describe what this material is, and how do you compare it to uranium, plutonium, germanium, gallium, and many other rare earth metals?
Lithium is the lightest metal there is. It's the third element in the periodic table and the first metal. The thing about that is because of its position in the periodic table of elements, it is an ideal material for a storage battery. However, it wasn't used. In fact, in 2007, I published my first list of rare metals, so to speak. I listed lithium in 2007 as a rare metal because it was produced at less than 20,000 tons a year worldwide. Silver was my benchmark metal, 21,000 tons a year in 2007. So 16,000 tons of lithium produced in 2007. This year, it'll be about 96,000 tons, 6 times as much. That increase is entirely due to the discovery that lithium could be used to make a storage battery of the type which is called a lithium-ion battery, which could be made large enough to propel a car or even a ship. In the last 15 years, the production of lithium was multiplied by a factor 6. So this was really brought about by the demand initiated by the Tesla Corporation.
Electric vehicles.
Yeah, the electric vehicle goes way back to the beginning of the 20th century. In fact, Henry Ford's wife was considered it to be unladylike to have to crank a gasoline-powered car to start it, and so she wouldn't drive one. The electric starter was invented in 1912, and this was before 1912. So Henry Ford's friend, Thomas Edison, built a battery out of nickel iron, and the engineers made her an electric car, and they kept doing that. And she died in the 50s, and she always drove an electric car on the family estate. The point is that why aren't we driving electric cars? Why the revival in the 21st century?
People are definitely advocating more electric cars, more use of electricity rather than the fossil fuels.
The problem is that batteries weren't good enough. They couldn't give you enough range in an electric car to compete with a gasoline or diesel-powered car. If you were to use sufficient batteries of the type available, let's say, at the end of the 20th century, they would be so horribly expensive that there would be no point to the car. General Motors built about 1,000 cars propelled by a battery chemistry called nickel metal hydride, which was a rare earth based. Those batteries were very expensive, and they didn't sell the cars, they leased them, and they had a range of about 160 miles. And they were, quite frankly, almost all leased into the California market, because that's where people wanted them. At the same time, General Motors discontinued that around the year 2000, recovered all the cars and destroyed them. Even though everybody who had one wanted to buy it, they wouldn't do it. At the same time, using this nickel metal hydride battery, the Toyota Corporation came up with a car called the Prius in 1997. And that was what's called a hybrid. Now that means that it has both kinds of power, battery and internal combustion. That turned out to be a real winner. They're still making them, and in the last 25 years, they've made about 2 million of them. So that is actually the most popular electric type vehicle in history, the Prius hybrid so far. And what happened was, in around the year year 1980, as I recall, rechargeable batteries were in great demand for something called the Walkman. It was the portable music player that preceded the iPod. It was made by Sony. It was very popular, and it used ordinary batteries, one-use, single-use batteries. And this was very expensive. And since it was young people who bought most of these things, the people at Sony said, this isn't going to work because they're going to figure out you pay more for batteries every year than you pay for the music player. Well, they took a look at a technology that had been being developed at that time, about 10 years. It was called the lithium-ion battery. It had been developed 10 or 15 years before by a Japanese scientist. Actually, the invention was by an American scientist who is still alive. He's 97 years old. I believe he just won the Nobel Prize. So Panasonic and Sony got together and they made this lithium-ion battery to power these music players and the portable music players and radios they had in 1980. Then there was parallel development. The lithium-ion batteries, rechargeable, got bigger and bigger. They could be made bigger and bigger, but there wasn't much lithium around, but there also wasn't a lot of demand, but the demand started growing because the batteries they'd been using to reach it were called nickel-cadmium. Cadmium is very poisonous, and the United States young EPA said, you got to stop doing this because they are going into landfill, and it's poisoning the water and the ground. So lithium-ion batteries caught on suddenly, and there was a lot of development. Well, the car companies weren't paying any attention because batteries weren't big enough, and you could make a lot of small batteries, but you start making a big enough battery for a car, and that few thousand tons of lithium produced every year is going to disappear pretty fast. In those days, as far as I can remember, all the lithium was coming from Piedmont, North Carolina, which was a lithium mineral deposit. That caught on, and people started looking for lithium. They weren't looking at lithium-ion batteries for cars in those days. They were looking to make them for portable equipment.
We certainly have to be sure that any of the materials we use for these new technologies, such as electric vehicles, are ecological and sustaining both in their extraction from the earth, in their manufacturing, and in their disposal. Can we utilize rare earth metals without destroying the environment in the extraction process, in the refining process, and when their life function has ended, can we reuse these materials?
The problem with recycling them is that you have to do the same chemical processes you did to create the original material. The answer to your question, in my opinion, is no. We're going to have to decide on how much pollution we can stand, and it's going to be a balance. Can we stand this much pollution in this area in order to produce these rare earths, the benefits from which will ultimately erase the pollution we caused by producing them? That's a question for ethicists to determine, not me.
One World Lithium's technology is to vertically integrate the production of battery-grade lithium carbonate directly from brines in a single reactor. And you're going to have to explain that in some layperson's terms. The company has signed a licensing agreement with the United States Department of Energy's National Energy Technology Laboratory Division for a patent developed by the National Energy Technology Laboratory for selectively recovering lithium from solutions of mixed metallic ions. Is the new processes better than in the past so that we aren't polluting the soils and the water and our air?
Yes, this is a marvelous development. In the last decade, I did quite a bit of work for the U.S. Department of Energy on peer-reviewing papers on research and development they were doing on recovering rare earths from coal. One of the contracts they had with several universities involved using carbon dioxide to precipitate rare earths from solutions made up from coal. I found it very interesting, and I thought it might be a really good process for the rare earth industry. And then I met the One World Lithium fellows, I think a year ago. They were telling me about a Department of Energy patent to use carbon dioxide gas to recover lithium from the solution. And I was astounded because I had done so much work on rare earths with that, and never thought about lithium. And of course, the Department of Energy is the largest employer of PhD chemists probably in the world. A very large group I was working with at NETL Pittsburgh never mentioned the work at NETL Albany, Oregon, where this process to recover lithium was being developed. I never heard of it. And so when I looked at it and did the numbers, I was astounded. It was the lowest cost system for recovering lithium I had ever seen from brine. In fact, it's not only only low cost, it's non-polluting. The carbon dioxide that's not captured in lithium carbonate, you use again. So it's very low emission, no solvents used whatsoever other than water. This, to me, is a hell of a breakthrough.
In fact, while traditional extraction methods yield about 40 to 50% of the lithium present in a mined or brine resource, this new process can extract up to 75 to 90%.
Right. In fact, it might even be more.
And also, the lithium extraction process doesn't require as much water.
It doesn't require water, any additional water. It actually has an exit stream of water. So, in fact, you don't need to add fresh water to the system. When you're processing lithium from brine, you're working in what's called a salar, a Spanish word for salt desert. The solution is brine, heavy duty. If you drank a glass of it, you'd probably die from it. It's so salty. The point is that you need fresh water to process it. But where do you find fresh water in a desert? That seems to be a contradiction in terms. Well, you don't. So these processing systems are built, they have to bring water, and they are big users of water. And in desert areas of the earth, that's not exactly considered to be a good use of fresh water processing chemicals. You don't need to add water to the system if you're using the carbon dioxide precipitation system. That immediately is a benefit environmentally and cost-wise.
You started working in 1962 on the
Correct.
Electronic properties of lithium.
That's right.
And you have been involved in this field for a long time, to the point where you developed a method to deposit cadmium sulfide in tubes the diameter of a human hair, which allowed the construction of a solid-state image intensifier, which is used in night vision binoculars for the Army and NASA.
Yes.
You actually made the first solid-state memory cell that came to the market 50 years later as the SSD.
Yes.
These are remarkable discoveries and inventions that you have created.
Well, it's been an enjoyable run, and even at my age, I'm 82, I'm still interested in these developments. And I can't say that I did anything like that on my own. They're always team efforts.
In 2007, you developed the term technology metals. What does
Yes.
that mean?
It means those metals, mostly rare ones, the electronic properties of which enable all of our technologies today. Electronics entirely depends on these technology metals. They've only become available in quantity since the end of World War II. This is a whole new era. The technology era began in 1945.
So these include copper, rare earths, platinum group metals, steel alloy metals, lithium, cobalt, graphite, and most of the rare critical metals and materials necessary for our health, safety, and technologies, both consumer and in the military.
Yes.
What new discovery do you think is going to occur in the next few years?
Fusion energy. If that happens, if we're able to produce electrical energy from controlled fusion, then all bets are off. We won't need any more coal, oil, or gas for energy if we do that. We'll only need them for chemicals.
You have certainly let us know about what is happening in this field of rare earth metals to be used in our new technology. Thank you for keeping us up to date. Thank you for being my guest.
You're welcome. Thank you.
I have been speaking with Jack Lifton, who is an advisor and physical and chemical engineer with One World Lithium. I'm Nancy Perlman. Thank you very much for joining us, and do tune in again next week.
If you would like free information about these environmental issues, go to www.ecoprojects.org or call 310-559-9160. Environmental Directions with your host, Nancy Perlman, is a community affairs program of the nonprofit organization Educational Communications and this station.